Hello class, sorry I can't be there today. However, we are going to continue our notes. The notes are day 2. It's on pages 7 and 8 in your packet. So if your packets aren't already out, they should be out to page 7. We're going to be talking about functions. A function is a relation between two quantities in which one quantity is associated with a unique value of the other quantity. So functions, it sounds a little confusing, but basically a function, we're going to use an example down here in number 2 in a minute. A function is basically for each input, there's exactly one output. For each input, there's exactly one output. And I'll show you what I mean in this example here with the vending machines. Alright, so I had a little animation to go with it, but in the interest in time, we're just going to kind of talk about it. We have this first vending machine. Alright, I'm going to call it vending machine A. Vending machine A here has 6 different buttons, A, B, C, D, E, and F. If you push button A, every single time you're going to get an orange juice. If you push button B, every single time you're going to get an apple juice. If you push button C, you'll notice it points to skim milk. So every time you push button C, you get a skim milk. Button D also gives you skim milk. So maybe everybody likes skim milk. There's 2 buttons for that. E, if you push button E, that gives you a chocolate milk. And if you push button F, that gives you water. Alright, so for each time that I push a button, I get one type of drink, either OJ, apple juice, skim, chocolate, or water. Now if I look at this guy, B, vending machine B, option A, if I push button A, every time I'm going to get an orange juice. Button B, if you notice, it is pointing to apple and skim. So sometimes you get apple, sometimes you get skim, which would be kind of annoying if you're going to a vending machine. You would like to get what you're choosing. You'd like to be able to choose apple juice or skim. You don't want to have an option and be at the mercy of the machine and what comes out. You want to be able to get either apple juice or skim. So this is an example of not a function, because button B gives you either apple juice or skim. So for each time I push a button B, I might get one or the other. There's not exactly one type of drink that comes out. So this is not a function. Okay, you wouldn't like it if you were pushing it wanting apple juice and you got milk instead. Okay, which vending machine represents a function? That would be the first one, the refreshments, or machine A. Because each button gives you one type of drink. Each button gives you one drink. Which vending machine does not represent a function and why? That would be machine B. Because button B can give you either apple juice or skim milk. So it's not really a function. Each input, each button that I push should only give me one type of drink. That's what I was referring to up here when I said each input has exactly one output. Each button should correlate to one drink, and that's it. So machine B, because button B gives you apple juice or skim milk. So it's not going to be a function. Okay? So we're going to be talking about functions. Eventually we're going to get into graphing functions and things like that, but right now we're going to get into what's known as function notation. Use function notation to represent the relationship between each code and the type of beverage that the machine delivers. So we're looking at machine A here. F of A. You're going to see this lovely thing with an F. This is pronounced F of A. That's how you would actually say it. All that means is if we push button A, what do we get? So if we look up here, button A is going to give us orange juice. So that would be our answer, OJ, or orange juice. F of B, that just means if you push button B, what do you get out? You get apple juice. So you put AJ, apple juice. F of C, that means if you push button C, what do you get? You get skim milk. F of D, if you look at D, you're also going to get skim milk. If you push button E, you're going to get chocolate milk. And then if you push button F, you're going to get water. So that is an example of what function notation looks like. It just means if you plug in A, what do you get? If you plug in C, what do you get? If you push button E, what do you get? The type of drink you purchase depends on the code you input. So you would say that the set of codes, A, B, C, D, E, and F, those buttons, is the set of possible values of the independent variable. Independent variable. An independent variable, I'm going to abbreviate it here, independent variable in a function rule determines what happens to another variable in the rule. The set of possible values of the independent variable is also called the domain of the function. All right, the independent variable kind of determines what you're going to get. So the buttons on the machine determine what kind of drink you're going to get. That's what an independent variable is all about. Independent variable, it's also going to be known as the x value. It's also known as the input. All right, it's also known as the domain. So that's an independent variable. Now, the different types of drinks that you get, flipping over to the back, form the set of possible values of the dependent variable. All right, dependent variable is kind of at the mercy of what button you push. It depends on the button you push. A dependent variable in a function rule changes its value when the value of the independent variable is changed. If I push button A and then I push button B, it's going to change the drink that comes out. The set of possible values of the dependent variable is also called the range of the function. A dependent variable, besides known as the range, it's also going to be known as the y value and as the output. It's what comes out after you push the button on the machine. Okay? We're going to kind of skip over this number 7 part, and we're going to go straight to number 8, talking about independent and dependent variables. Now, let's say that you have a bunch of pumpkins, and you're going to be making pumpkin pies. So number of pumpkin pies, there should be an S there. We want to figure out what's going to depend on what. That's where we're going to write our dependency statement. It's going to be something depends on something. That's what a dependency statement is. We're going to figure out what depends on what. Now, if you have a lot of pumpkin, you're going to make a lot of pie. If you only have a little bit of pumpkin, you're going to only make a little bit of pie. So the number of pumpkin pies, so the number of pies is going to depend on the amount of pumpkin that you have. You just kind of have to look at the situation and figure out, okay, what depends on what? Our number of pies is going to depend on how much pumpkin I have. If I have a lot of pumpkin, make a lot of pies. If I only have a little bit of pumpkin, then I have a little bit of pie. Once you figure out what depends on what in the situation, since it depends on the amount of pumpkin, whatever it's depending on, this thing after the depends on part, this is known as the independent variable. Independent variable. So whatever it's depending on, that's the independent variable. So that's going to be the amount of pumpkin. And then the thing that's actually depending, the number of pies depends. The number of pies is going to be your dependent variable. So you got independent, dependent. Whatever's depending on something, so the number of pies is depending on something, that's your dependent variable. And then this part afterwards, that's your independent variable. Pumpkins are going to determine how many pies you have. So that is dependent, independent. We'll talk more about it tomorrow as well. Now the last part is using function notation. This is kind of like when you have to do the pop machine, where you're figuring out, if I put in button A, what do I get? If I push button B, what do I get? Same thing here. If you notice, this one says f of -9. This is how you would say it, f of -9. What that means is, you notice there's an f. So we're going to be using this equation here. The other one's got a g. We're using this guy. All this means is plug in -9. That's all it means. So we have f of x equals, it's 3 times x, but we're plugging in -9 plus 7. So you're just plugging it in. You get -27 plus 7, you're going to get -20. So all you do is figure out which equation and then plug that number in for x. That's it. That's all you're doing. Same thing here. B got g of 5. Since it's g, we're going to be looking at this equation here, and we're going to plug in 5. So we have x squared, 5 squared, minus 5 times 5. Don't forget order of operations. You get 25 minus 25. Your answer is 0. Okay. G of -7, that means you're going to go to the g equation and plug in -7. So we have -7 squared minus 5 times -7. -7 squared, remember, is 49. This times this is actually positive 35. And then you get 84 for your answer. This one's kind of hard. You're going to have, it's like two problems in one. F of 15 means you take 15 and plug it into the F equation. So you're going to have 3 times 15 plus 7. And then G of 3 means you're going to be plugging in 3 into the G equation. And then once you're done, you'll add them together. So this guy, 3 times 15 is 45, plus 7, you're going to get 52. This guy, you get 9 minus 15, or -6. Add them together, and you're going to get -46. So this one's kind of like 3 problems in one. Find this, add. So that's function notation. It's just a little intro. We'll do more with it tomorrow. Your assignment that you should be working on now is worksheet number 2. It's pages 9 and 10 in your packet. All right, so go ahead and get started, and I will see you tomorrow. Thanks. Bye.